Greetings and welcome, friends. Mr. Waddy here and my fellow geometricians. We were talking yesterday about proving triangles congruent without having to go through the work of proving all corresponding sides and angles were congruent, because that's a lot of work. That's 6 pieces of information for each no, for both of those triangles. No, thank you. No, thank you. So we have a new theorem, the side angle side congruence theorem, which allows us to prove 2 triangles are congruent with only 3 pieces of information, namely 2 pairs of sides being congruent and a pair of angles, specifically their included angles. So if I have 2 sides, the included angle is the one that has a vertex where those sides intersect. So it says here, name the included angle, right? Nice, easy, underhanded pitch. Here we go. PK and LK. So PK and LK, the included angle is going to be this one right here, the one that is right adjacent to those 2 sides. So I could actually just call that PKL, something like that, or LKP. Either of those would have worked. Also, notice that both of these have K in their name, so that's got to be the vertex right there. That's kind of like clues right there. And similarly with these ones, the vertex has to be at P, even just looking at the names, even if I didn't have a diagram to consider. But KP and PL, the included angle there would have been this one. So yeah, so angle KPL would work just fine. So that was just practice as far as identifying an included angle. Now, here what we're doing is trying to determine that whether or not I could use side angle side to prove the triangles congruent based on their information, or maybe there's like a couple short steps of information I could make that would get me there. So so for these 2 triangles, question 9, what are our thoughts? Anyone want to share some thoughts on this one? I didn't pick them in order for us. Is there? I've got 2 sides and 2 angles, so I need another side. Is there a side that I can find? Yeah, reflexive property. That's a classic. And I can't find anything else out at this moment. Does side angle side apply? I've got 2 sides and an angle, but the problem is that the angle is a non-included angle. I would need this angle and this angle, right? I need the angle that's in between the 2. Question, comment? Mm-hmm. Well, I would know that like these 2 angles would have to be supplementary with this one, you know, like they're going to add to 180, and these 2 would add to 180 with it as well. But these could be of varying sizes. The situation that we actually have is an angle side situation, and there is no a $sign theorem in math. It just doesn't work, not because it's just, you know, inappropriate, but also because it's it actually won't logically work out. We will examine that later on, and it turns out that there are 2 possible arrangements that these triangles could land in when you have an angle side situation. So you could argue maybe it's a 50-50 chance that these were congruent. I don't have sufficient information to conclude 100% at this point. So this one's a no for that reason, primarily because it didn't have the included angle. How about over here? Any other information I can gather? Yeah, the middle reflexive, and then this is an included angle between those 2 sides. So yes, right, by side angle side. Sounds great. How about over here? Other information I can gather. Yep, reflexive, always aim for that. I also could say that angle NKM is going to be congruent to LMK by what means? Yeah, parallel lines cut by a transversal, and those are alternate interior angles. So alternate interior angles theorem, I could conclude that. These are two sides in a non-included angle, though, so it's a no-go. Technically, like, if I extended these parallel lines, you could even say something like this and this. But, yeah, there's not enough. There's more things that I can say, but not enough that would allow me to conclude these are congruent, so no, because it's a non-included angle. It's another angle side-side situation. These ones? For these angles, we can't, because those angles would be requiring these lines to be parallel and cut by a transversal. So if I had that information, then I could, and I'd be golden. But yeah, I can't. I don't have a way of concluding that those two lines are parallel at this point. But yeah, so that's why I really like these types of problems, just to get you guys thinking about these kind of more quickly than having to write a full proof. Bless you. Bless you. All right, so let's see. Here's a good problem. Kind of looks rectangular, not necessarily though. It's just some sort of quadrilad statements and liaisons. Let's see. Let's start with our given information, and for sake of efficiency, I let you kind of shorthand that, but in a formal proof, you would kind of need to write some more information there. So let's see, this is labeled. This is good. Actually, could you shut the door, please? Thanks. AB is congruent to CD. We got it. Yep, and AB is parallel to CD. So what's some other information I can go with here? And if these angles weren't named that way, you technically can add information to a diagram. Like, you could rename something if you want to have like a shorthand way to refer to it. So you could have even thrown in something like that of your own accord. Angle 1 congruent to angle 2, why is that? Yeah, alternate interior angles theorem, well done. So that's, I've got side and angle, I need another side. AC is congruent to itself. Classic reflexive. And I believe I've got my side angle side situation, so I can say that triangle. Yeah, we can assume that they wrote that correctly, but it's still a good idea to verify. Triangle ABC is going to be congruent to triangle. So ABC, it's starting there, so we're going to have CDA. Yeah, and that's what they wrote as well. Yep, and that's actually a really good point, that these two are interchangeable. They were not logically dependent on one another. And actually, I believe even some of the proofs on the test for this chapter, there will be like complete multiple ways. Like there will be proofs where you might use this one and I might use a completely different conclusion reason and have different requirement evidence that I provide. So proofs is one of the cool things in mathematics where it's an open-ended question in a way that you can kind of prove it through your own means as long as you obey the laws of math. Oh yeah, oh yeah. This is a big chapter for proofs. Oh, it's gonna be good though. I'm gonna train you up. Fortunately, most of these have nice short 3-letter acronyms for the proofs. All right, feel free to use any English vocab that you could apply in a paragraph proof. Yeah, man. Let's see, here's some given information. Now, I actually could prove these two triangles congruent or these two triangles congruent, so let's actually see what we're aiming for. We're aiming for PQT. So we're looking for these ones, yeah, kind of the obtuse looking ones. I'm assuming those are obtuse. Looks like it. So if I want to prove those congruent, what should I go for next? Yeah, vertical angles theorem. Yep. So I could say that this is congruent to that. And then, yeah, we have vertical angles there as well, but that wouldn't help us for this particular set of triangles. And that's another thing to be aware of with proofs. You might be able to say a lot of information is true, but it might not be helpful in you reaching your conclusion. Although, like, I wouldn't mark you wrong for that. And as you're kind of like open-ended trying to find your path towards that proof and that conclusion, I'm fine if you write down additional information, even if it's not going to help. If you're just like, all right, I know this, I know that, I know that. How can I fit these pieces together to get where I want to go? And let's see, lastly, we've got then triangle PQT is going to be congruent to triangle RST. Now, technically, in terms of triangles, these angle names would not have lined up if I was talking about triangle congruence. But as far as angle names, I don't get picky. Like, I'm fine the fact that, like, you didn't name it in the sequence of this side and this side first. It doesn't matter to me. Angle names don't matter, but for triangles, the sequence will be more important. And this is true by side angle side. And let's see. Oh, here we are. Oh, it looks like I didn't give myself enough space. Ah, well. All right. Oh, dear. Oh, I'm jumping all over. All right, 1922. It says, use the given information to name two triangles that are congruent. Explain your reasoning. All right, so this one's going to be a little bit less formal, but we were told this is a regular pentagon. Actually, have we even defined the word regular yet? I don't remember. Regular means that it's both equilateral and equiangular. So by definition of regular, all of these exterior sides are going to be congruent, and all of these angles will be congruent. All right, all of these kind of, I guess I can't technically call those exterior angles, but the border angles, I don't know, are going to be congruent. And based on that information, I think I could show that this triangle is going to be congruent to this triangle. All right, so I could say that triangle stew, because I can, is going to be congruent to UVR or RVU, because these triangles happen to be isosceles and symmetric. So I'll just call it UVR. And the reason that's true is by side angle side. Yeah, so some of that would have been by, right, definition of regular, sort of thing like that. And let's see, let's do a construction. Lastly, all right, let's see if I remember how to do this from Ski-Ratch. All right, so you guys can take out your, I guess, all right, I was going to do it like at a weird rotation of the original, but maybe that's not as helpful. I won't do that. So let's start with some, all right, some ray, I guess, right? Pick a point. I could call this point D, right? I've got a ray traveling off forever. And I'm trying to prove this by side angle side. So I've got that. I'm going to now use my compass tool, and I want to measure out a congruent side. So I'm gonna scale this so that it's of length AC, something like that, maybe. And so now I can go out here and measure, swipe, swipe. There is going to be a length of AC. Let's see, so here, so I could call this D, this point's going to be E, so I'll call this F. Right? And I can even draw that line, although I'll probably end up retracing over it there, that segment. Okay, now I could measure the length of AB, so yeah, these are congruent, and find all possible AB lengthed points away from D, but I'm actually more interested in matching this angle first. So let's see if I can do that. This is the one that I'd probably just kind of start making swipes and then see what makes sense here. So let's see. So I would want, oh man, and it's obtuse. Yeah, that's going to be annoying. And I can't fit it There we go. I'm gonna rotate this way. All right, so I've got this arc that I'm measuring out here. No, that's actually not going to do it. Guys, I think I've honestly forgotten. Right, but we use just the straight edge and the compass here. All right, so I'm going to need... Have we constructed an obtuse angle yet? Yeah, I mean, I suppose I could construct the supplemental one to it first. Actually, I think I've got an idea. Look at this. I've got this purple arc is currently of length AB. If I go to point C and expand up to measuring... That's not constructing an angle. That's doing side... I'm doing side, side, side there. But yeah, see if I do this, I would get that point. And if I do this, right, then that's the right point. But I technically, by doing that, I'm doing a side, side, side. I don't think I'm doing a side angle side, unless it happens to be the same thing. Did I just open up my symmetric tool? Yeah, I did. All right. But yeah, so here we go. This would be my point E. Liam, right? So there's point E, and here's a triangle. I might have kind of broken the rules here. Yeah. But there it goes. Yeah, I don't think I technically constructed that angle. I think I constructed 3 congruent sides. Well, either way, I'm fine with it for now. Thanks for watching, internet friends. Adios.